Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over surface area of prisms and cylinders. I want you to notice that there are two attachments in your Shobi notes. So the first one has to do with some prisms, and then that second one is the cylinders. We're going to do both, so pay attention to when I leave those prism notes and go to the cylinders. So first, prisms. We had an assignment yesterday over looking at what we call nets. This three-dimensional rectangular prism on the left shows it all opened up, all the surfaces laid flat on the right side, and that's what we call a net. So what we're going to be doing is finding the surface area. So finding the area of every single one of those surfaces. So think about opening up a cereal box and laying that cardboard flat. All of that cardboard represents the surface area. So what we need to do is find the area, what we call the lateral faces here in blue. And then there's always two bases in a prism. And that's kind of where they sit on. Not always, but then that also defines the shape that they are. So we could take a net and find the area of each one of those faces and add them all together. And there's also a formula we could use for rectangular prisms. So I'm going to show you the formula, but I'm also going to remind you that if you don't remember the surface area formula for a prism, then you just find the area of all the surfaces and add them up, all the faces. So the surface area formula, there's a couple different ways that you see it. You may see it as twice the length times width, plus twice the length times height, plus twice the width times height. So that's one way. You may also see the two out front, or you may see it as the length times the width, plus the length times the height, plus the width times the height, and then all of that multiplied by 2. All right, basically what this formula is showing or is saying is that there is a surface. So let's take, for instance, this base that it's sitting on. So that's a rectangle. And then directly parallel to that, directly across from it, this other rectangle that's identical to it. So if we find the area of one of those, we can multiply it by 2 to find then both of them. Same thing with then the other two sides as well. So let's start with naming the length, the width, the height. So you could, depending on how you're looking at it, so we know right now the way that it is sitting, that this would be the height, the 6 inches. It looks like the 3 would maybe be the length and the 5 inches would be the width. It really doesn't matter which one you name which, as long as you are giving one of them the height, one of them the length, and one of them the width. Because technically this prism, we could turn different ways and we could look at it a little differently. So in our formula, I'm going to put over here what we just identified. The length, and I already don't remember, it was 3. The width was 5. And then the height was 6. And once you find those 3 measurements, well, then you can just plug them straight into your formula. You can show your work using that formula, and then you can use your calculator to find the total surface area. So 2 times 3 times 5. Notice I am simply putting 3 in for the L, 5 in for the W. And then plus 2 times 3 times 6, again just replacing my L and my H, plus 2 times 5 times 6. And then we could multiply all these out, and we want to multiply first, then add. So 2 times 3 is 6, 6 times 5 is 30, plus 2 times 3 is 6, 6 times 6 is 36. And then plus 2 times 5 is 10, 10 times 6 is 60. And then we could add all of this together. So the total surface area, 30, I'm going to add my 30 and 60 first, so that's 90. And then 90 plus 36 is 126. Surface area, we always label, so it was inches, and area is always squared. We're looking at the number of square inches that would fit on the outside on all the surfaces of that rectangular prism, okay? And here, I'm going to show you, since I showed that in the first part, 2 times 3 times 6 is where we got that 36. 2 times 5 times 6 is where we got the 60. Now, I do want you to know where those came from. So if we were finding that red part that I outlined, the bases, so that would be 3 times 5 to find that bottom base, and then times the top to get the top and the bottom. So that would be our 2 times 3 times 5. So that is this part that takes care of the two bases. Okay, now the next part, if we look at maybe the sides, so we have a right side here, so we want to look at those dimensions. That's 5 inches by, then the height is 6. Then notice directly parallel to that, so the left side over here is the exact same rectangle, and it actually goes up over there. So 5 times 6, and then we'd multiply it by 2 to get those two green parts. So that is actually the end of the formula, 2 times 5 times 6. And then the last part is actually your front and your back. So this front rectangle is 3 inches by 6 inches. And then there's the exact same rectangle in the back of the shape. And notice the rectangular prisms have 6 surfaces, 6 rectangles. So 3 times 6 is that front shape, and then we multiply it by 2 to get the back one as well. So that's that part of the formula. So sometimes we may not find the total surface area. Maybe we're just finding the lateral faces, and then we wouldn't count the bases, which was what we had in red. And so maybe we would say, oh, I'm going to put it over here, our lateral surface area would just include the front and the back, and then the right and the left. So that would include your 60 plus 36, so that would be 96 square inches. So be careful, always make sure you notice what they are asking for, and maybe they're just asking for the base area. The base area then would just be the 30 square inches. So just giving you some extra examples of different types of examples you may see. So there was a rectangular prism. Now we are going to do a triangular prism. There is no formula for this. Basically, you just want to find the surface area of all of these sides. Notice that it's a triangular prism because the base is a triangle, and then the sides are all rectangles. So we're going to find the area of the two red triangles, the top and the bottom. I guess I missed that bottom. We're going to find the right rectangle, that blue. We're going to find the left rectangle, this green. And then we can't forget there is the back of this, the very back there that we can't see. So we also need to find that rectangle. So there's actually 3 lateral faces and then the 2 bases, so 5 total faces to find the surface area. So let's start with the triangles. So the area formula for a triangle is either 1/2 times base times height, or you can find the base times height and divide it by 2. Now, there are 2 triangles, so we're actually going to have to multiply this by 2. So you always want to look for that right angle in your triangle. The base and the height are what form that 90-degree triangle. So that 5 is not considered the base or the height. The 3 and the 4 are actually where that right angle was. So we do 3 times 4 and then divide it by 2. So 12 divided by 2. So one of those triangles is 6, and they're meters, so meters squared. Now, the triangles, there's 2 of them. So we are actually going to take that 6 and multiply it by 2. Now, some of you may have seen that since there were 2 triangles, we actually didn't have to divide by 2 because we were going to multiply in the end. But if you didn't see that, then you may have divided by 2 and then multiplied by 2 to get the 2 triangles. Okay? Now, we're going to do the right rectangle, and it kind of depends on how you're looking at this. Sometimes you could look at them different ways. So you want to make sure you're using the right dimensions. So that's 4 by 6. So we do 4 times 6, and we'd get 24 meters squared. So that's the right rectangle. We're going to do the left rectangle. So that is 3, and then again by the height, so 3 times 6, and that gives us 18 meters squared. And then one last rectangle that we need, and that is the back behind that we can't see, so that is 5, and then the height by 6. So the back rectangle. And the importance is that you don't miss out on any of these sides. So that was 5 by 6. And that's why I labeled all these sides to make sure that I didn't miss any. Once you are done, then you want to make sure that you find the total surface area. So we would add all of these together. 12 plus 24, so that gives us 36. Oh, plus 18, 54. And then 54 plus 30 is 84 meters squared. And I think I got that all right. And let's double check. We got 12, 13, 14. Looks correct to me. So there is the total surface area of all of those sides in the triangular prism. Again, it would maybe be a question where you're maybe just finding the lateral sides. And if that were the case, then you would forget about those two triangle bases and just add the 24, 18, and 30. Just depends on the type of question. So there is surface area of prisms. Now go out, and then there is a second page with our cylinders. Again, the cylinders have a formula. And the formula that I'm going to give you, there is the base and the lateral surface area as well within the formula. So the surface area for a cylinder is 2 pi r squared plus 2 pi r h. And what this means, the 2 pi r squared, so pi r squared, just the pi r squared is the area of a circle. And then when we multiply it by 2 in front, well, then that is the circle on the top and the bottom. And it depends on how your cylinder is facing or sitting. But the two circles, the top and bottom circles, are the 2 pi r squared. So that is what we call the base area. Then the 2 pi rh, so 2 pi r is actually the circumference of a formula. So around the outside of a circle times the height, well, that is your circumference times the height. That's the rectangular part on the outside, the lateral area of the cylinder. So if you are only asked for, and I'm going to remind you that this is the curved part of the cylinder. So again, you may be asked to find just the lateral area of the cylinder, and you'd only use then the 2 pi rh of the formula. So be careful. If you're finding the total surface area, though, you will find all of that formula. And that's what we're going to do in this first example. So find the surface area of the cylinder below, round to the nearest tenth. So we have two labels here. We have the middle of our circle to the outside, so radius is 13, and then the height of the cylinder is 19. So I'm going to write down my formula that I just told you, 2 pi r squared plus 2 pi rh, and I'm going to replace everything that I need to. So the r we know is 13, so instead of r, I'm going to write 2 pi times 13 squared, and then plus 2 pi, r is 13, h is 19. Now, from here, personally, what I like to do is multiply everything but the pi and then add them, and I don't multiply anything by pi until the very, very end. So I'll show you what I mean by this. So in the beginning there, we're doing 2 times pi times 13 squared. So I'm going to include everything except for pi. So 2 times 13 squared, and that's 338. So like I said, I just did 2 times 13 squared. So 338. I haven't multiplied by pi, so I'm going to leave that there. Then the second part, again, I'm going to multiply everything except for the pi. So 2 times 13 times 19 is 494. The reason I'm doing this is sometimes we are asked for the exact surface area, and I think it was 494. And what that means is an exact answer would include pi in it. So then we would take our 494 plus the 338, and we get 832 pi. And we can add these because they both have the variable pi on them. So 832 pi, that is our exact answer, our exact surface area. However, this example told us to round to the nearest tenth, so we're actually going to take that 832 times pi. We get 2,613.8. So the total surface area rounded is 2,613.8, and this was labeled in millimeters squared. So that is our rounded surface area. Okay, again, remember that maybe I would ask you for just the base area. So the base area would be our 2 pi r squared. It would just be 338 pi, or 338 times pi if you wanted to round it. So be careful, make sure you know what those two parts of the formula stand for. Next example, we have a cylinder, no picture, but we are told that the diameter is 12. So if the diameter is 12, then we know the radius is half of that, and we know the radius is 6. And then we know the height is 8 centimeters. Make sure we never ever use the diameter in a surface area formula for cylinder. So make sure that the diameter you know is all the way across, and we need the radius. We only need that 6. The height is 8 centimeters. If you really wanted to, you could draw a picture. I'm no artist, not very good at drawing those pictures. So again, I'm going to include my formula 2 pi r squared plus 2 pi r h, and then we want to replace the r and the h with what we're told. So 2 pi times 6 squared plus 2 pi times 6 times 8. I'm pretty sure is the height, correct. So again, we can multiply everything. I am going to wait to multiply anything with that pi until the very end. 2 times 6 squared. So we get 72 pi for the base area. And when you do this, you can just multiply everything that's there except for the pi. 2 times 6 times 8, so we get 96 pi for the lateral area. And then last step, you want to add these, so 8, we get 168 pi. Again, the reason I'm doing that is you may be asked for an exact surface area that's with pi in the answer. In this case, we're going to round, and I want to make sure I did that right. 168 times pi is 527. We'd round up to 0.8. So the total surface area, 527.8. This was labeled with centimeters squared. So there is the rounded total surface area, including the bases and the lateral. So there's how you find a surface area of prisms and cylinders.